couple of things, right? So just starting with the general structure of the heart, right? So the atria are the top, the ventricles are the bottom. And this model actually does a really good job of showing the musculature difference, right? So the atria have pretty much none, like hardly any at all. The ventricles have a lot, okay? And that's because the ventricles are the ones that are responsible for pumping blood to the lungs and then to the body, right? And you can see that this has even more musculature than this, right? So what that's telling you is that this is the one that's pumping to the lungs because it's kind of a short trip, right? This is the one that's pumping to the entire body. And so the division of labor in the heart is kind of, they say like this side is the pulmonary side, right? Because this is the side that's going to drain into the lungs. This is the systemic side because it's the one that goes into, the whole body, the whole system. Let's see. So you're going to have to know these two valves, right? So this one is the tricuspid valve, right? So this separates, right, atrium from ventricle. And it's got three kind of anchoring points and three, like basically each one of those is like a door. And these cords that connect like one of the doors of the valve to the heart itself, these cords are called the chordae tendineae, which pretty much just means like tendinous cords. So there's that. And then they don't show them super well, but there are muscles that kind of pull on these cords, and those are called papillae. Like I said, you can't really see it, but that's what they're called. On the other side, separating atrium from ventricle, you have the bicuspid valve. Okay, that's this one. And so you've got the chordae, right, for left and right door openings, basically. And then the papillae will control that. And so there's like a functional reason for why one is tricuspid, right, with the three doors. And if you look up there, actually they're drawn out, right? So the bottom one is the tricuspid valve, and the top one is the bicuspid, right? So bottom one has three doors, basically. Top has only two. There's a reason for that. So when you have a valve with three kind of openings, it allows it to open a lot wider than if you only had two, right? However, it's also got more seams for backflow and leakage, right? So it's not quite as secure, but it does allow more blood flow. And so the reason we've got that on this side, because this is the side that drains into the lungs, right? And so what you've got is a whole bunch of kind of low-ish pressure blood coming in and then going into this ventricle and getting pumped out. So the valve that separates basically the atrium with the incoming blood from the ventricle that's going to pump the blood into the lungs has those three doors because having that extra wide opening is helpful for draining, and you don't need to worry so much about having that kind of greater potential for leakage with the three doors because the blood is relatively low pressure that's coming from here to here, right? So what's going to happen is the oxygen depleted blood is going to come up into this atrium from This is the superior vena cava. This is the inferior, right? So they're coming in to the atrium here. And basically what happens is, like, eventually a whole bunch of blood is in the atrium and it gets kind of heavy and it exerts enough pressure on this valve to open it up, and the blood flows into the ventricle. But then the ventricle is full now, so it applies pressure from the blood back to close that valve. Okay, so then now you've got the blood pressure in here, and that can sometimes be kind of a lot in the ventricle. And so the reason you have these chordae tendineae that are controlled by the papillary muscles, or papillae, I guess, is because you don't want there to be so much pressure being exerted from this side to basically blow the door out the opposite direction, right? You know, because, like, think about if you could apply enough pressure on a door to shove it the opposite direction of the hinge if there was enough. And so basically what these chordae are doing, controlled by those muscles, is they're like pulling against the upward pressure from the ventricle. So they're keeping it so that the door stays closed without bursting the opposite direction. So that's what these are for. And again, the pressure here is not super ridiculous because it's on this side of the heart. But that's what those are for. Okay, so then, blood goes out, comes back in to the other atrium once it has blood from the lungs, fills up this atrium. Same situation as the other side. Once there's enough pressure is enough to open up this valve, goes into the ventricle. The ventricle exerts pressure upward to close that door. There's more pressure in this one, which is again why there's only that one like seam. And then the chordae make sure there's no backflow, and then this blood goes to the rest of the body. And yeah, that's it.